In this video, I'm going to show you and remind you on how to convert between forms. So before we go to the chart, I'm just going to refresh on all the different techniques we've learned when dealing with quadratics. So first thing, we know we have factored, standard, and vertex form. Regardless of if you're in factored form or vertex form, if you want to get into standard form, you just have to do some expanding. So that distributive property, which I'm just going to short form as FOIL. So from factored to standard, FOIL. From vertex to standard, FOIL. And now I'm going to go from standard form and branch out. So if I'm in standard form and I want to go to factored form, then I'm just going to factor. And remember, for factoring, look for a greatest common factor, then check to see if it's a simple trinomial or a complex. And you can always use decomposition if you want, but look out for those shortcut methods to make your life a little easier. Then from standard form to vertex form, we're going to complete the square. Now let's say I want to go from factored form straight to vertex form. I really don't want to take my factored form and expand it to get into standard form and then complete the square to get into vertex form. I really don't want to do that, especially if I don't need standard form for anything. So if I want to go from factored straight to vertex form, I can average the zeros, and that will give me my vertex, which I can then put into vertex form, or maybe I just need the vertex. And then finally, maybe I want to go from vertex form straight into factored form. Maybe I need the zeros. Okay, and again, maybe I don't want to expand to get it into standard and then factor to go to factored form. So to go from vertex form to get our zeros, we can solve by isolation. So we're going to refresh on all of these methods. Now, I want to point out that averaging the zeros and isolation, those are the methods to get the specific property, but then after that, once you have the property, you can put it into the appropriate form. Now, typically, if you want a certain property, you don't need the form, you just need to do the process. I'm just going to show you everything in this video, and then you can practice from there. So let's start off. Let's say you're starting from standard form. And I'm going to fill in the first box, which I've shaded in here. And if I'm in standard form, we know that gives you the y-intercept. So I'm just going to state my y-intercept. And we know that in standard form, the y-intercept is that constant at the end. So it's 0, 14. And we also know that the parabola opens up because that a value of 2 is positive. So there, I got a few properties. Now, let's say I'm given standard form and I want to convert it into factored form to get my zeros. So let's go ahead and factor this. So first thing I notice is that there's a common factor of 2. So I'm definitely going to factor that out because that makes my life easier. So I'm left with x squared minus 8x plus 7. Now I notice I have a nice simple trinomial. So I need two numbers that give me a product of 7 and a sum of negative 8. And those two numbers are going to be negative 7 and negative 1. So y equals 2, x minus 7, x minus 1. So I got it into factored form. That's wonderful. Now, if I'm in factored form, I know that gives me my zeros. So I know right away that my zeros are positive 7, 0 and positive 1, 0. Now I do want to refresh on something. If you are asked to solve for your zeros, a good communication form is to set your y equal to 0 and then solve your brackets. So let me just show you that. And then you can branch off to get those two zeros, and that's just good communication. And the reason we do that is because for your x-intercepts, the y coordinate is always 0, so I set y equal to 0. So there we go, we went from standard to factored. Next, let's go from standard to vertex. We're going to pretend we don't have the zeros, that's why we're not going to average anything. So here, if I want to go from standard straight to vertex form, I'm going to complete the square. And our first step is to factor out that a value only from the first two terms. And now we have to figure out that magic number that we're going to add and subtract to our bracket. So I'm going to take this negative 8 and divide it by 2 and square it. So negative 8 divided by 2 is negative 4. Squared is positive 16. So I'm going to add and subtract 16 to my bracket. And don't forget about writing that plus 14 at the end. And now, this negative 16 is useless to me, so I'm going to kick it out by distributing that 2 in. And now in my bracket, I'm left with that nice perfect square trinomial. And then 2 times negative 16 is negative 13. And once I collect those like terms at the end, I'll have my k value. So let's factor the perfect square trinomial. The square root of x squared is x. The square root of 16 is 4. And that middle sign of 8 is negative. So I have x minus 4 squared. And then negative 32 plus 14 is negative 18. So now I know that my vertex is 4, negative 18. And then I also know that the axis of symmetry is x equals 4, and I know that my optimal value is negative 18, which I know is a minimum because my parabola opens up. And there we go. We went from standard form to factored by factoring and standard form to vertex by completing the square. Now, let's say we start off with factored form. And if I want to go into standard form, I'm just going to expand and simplify. And in this case, it's just a quick FOIL. So x times x, x squared. X times negative 8, 2 times x, and 2 times negative 8. And then make sure you collect your like terms. And now from standard form, we know that the y-intercept is 0, negative 16. Now, if you were in factored form and you just wanted the y-intercept, but you didn't want to expand, you can always set x equal to 0 and solve for y, because we know for a y-intercept, x is always equal to 0, and we want to know what the y value is. All right, so for that, we just expanded. Now, in factored form, we know we get the zeros, so I'm just going to fill this in with our property, and I'm going to write the good communication form, which is set y equal to 0 to show that I'm solving this equation. And then this is a simple example because it's a simple trinomial, but if it weren't and you needed to solve for the zeros, you're setting your bracket equal to 0 to isolate for x. And I'll do the shortcut way for the other one. But I know my zeros are negative 2, 0 and positive 8, 0. So here I just wanted to show the property. Okay, next, if we're in factored form and we want the vertex, or we want vertex form, if I already know my zeros, I can go ahead and average the zeros. So I know my zeros are negative 2 and positive 8. We said that from above. So I'm going to average them. And when I average them, I'm just adding them up and dividing by 2. So I get 6 over 2, which is 3. That is my axis of symmetry. Okay, it's the line that cuts that parabola in half. So if I have the x-coordinate of my vertex, I can now plug it into my equation, into standard or factored, but in this case we're given factored, and then simplify. So y equals, and instead of x, I'm going to write 3, so 3 plus 2, and 3 minus 8. And we get 5 times negative 5, which is negative 25. So we know that our vertex is 3, negative 25. And now if the question just asked you to get the vertex from factored form, you'd be done. But if you have to actually find the equation in vertex form, now that we know our vertex, we know the h and k, and just looking at our standard form here, or my factored form, sorry, I can see that my a value is 1 because there's nothing in front, and then the coefficients of x are both 1. So I know my vertex form would be y equals a, which is 1, but I'm not going to write that, bracket, x minus 3 squared minus 25. Remember, in the bracket, it's always the opposite sign. So there we go. I have my vertex form and I have my vertex. And now finally, let's say we're starting with vertex form and we want both standard and factored form. If I want standard form, I'm just going to go ahead and expand and simplify. Now I want you to be careful and remember that you have to write this x plus 1 bracket 2 times so that you can actually do some expanding properly. I don't want you to write that x plus 1 squared is x squared plus 1 squared because that is completely incorrect. So I'm going to FOIL here for the x plus 1's so that I have x squared plus 1x plus 1x plus 1 plus 12. Now I'm going to distribute that negative 3 in, and then I'll collect my like terms. So negative 3x squared minus 3x minus 3x minus 3. And be careful with your signs there. Now, if you wanted to collect your like terms in the bracket first, you're more than welcome to do that. I'm just going to do all my collecting at the end. So negative 3x squared minus 6x plus 9. And now I know that my y-intercept is 0, 9. I'm just going to squeeze it there. Okay, now let's say we're going from vertex form and we want the zeros, or we want factored form. Now, if I really want my zeros, I can expand and get into standard form and then factor this. But I don't want to do that because that's a waste of time. So just like anytime you want zeros, we're going to set y equal to 0 so that we have an equation to solve. And now we see that perfect method for isolation. So I'm going to bring the 12 over. It becomes negative. And remember, with isolation, your goal is to isolate for that bracket squared. That's our first goal. And I'm going to divide both sides by negative 3, which gives me positive 4. Now I have that problem of I need to get rid of the exponent of 2, so I'm going to square root both sides. And hopefully we remember that the square root of 4 isn't just 2, it's also negative 2. So I have two equations here. 2 equals x plus 1 and negative 2 equals x plus 1. And now I can solve each equation by bringing that 1 over. So 2 minus 1 is 1. Negative 2 minus 1 is negative 3. So now I have my zeros. Now, if you just wanted the zeros, you're done. You have them. You know what the x-intercepts are. But if you want to put it into factored form for some reason, then I can just take those values and put them into brackets. But we know that the a value should go first, and we can see in vertex form that the a value is that negative 3 at the front. So I'm going to write my negative 3, and if my x-intercept is 1, I should write x minus 1. And if the x-intercept is negative 3, I should write x plus 3. And there's our factored form. Now typically, if you're given a form, you won't need to convert it into the other form. Usually you'll be asked for the property, which we already got. But this is just an extra little step I wanted to go over. And finally, in vertex form, we know we get the vertex. And the vertex is negative 1, positive 12, which means my axis of symmetry is negative 1. My optimal value is 12. And because the parabola opens down, so it looks something like this, we actually have a max of 12. So there we go. We have all of our properties, we have all of the forms, and this organizer here goes over absolutely every single method you can possibly use when you have quadratic relations and you're trying to find different properties or different forms.